Okay, so now we're going to talk about application of vectors. Now these are just a very narrow window of what you can do with vectors. There's a lot that you can do with vectors. We're going to stick with right triangles. A lot of times in the past we've gone over and we've talked about using law of sines and law of cosines. So when you have vectors and they're not at a right angle at some point. But for us, we're going to just stick to right angles for this one. And there's a lot more applications than even what we're going to get into, but you can really see how much science, how much just real life information comes from vectors. So today we're just going to look on getting kind of a better feeling how to use vectors to solve these word problems. All right. So is to make a sketch. Just go show the forces acting on a ship, and the ship is traveling at 23 knots at an angle of 17 degrees with a current. All right, and then find the force that the current is exerting on the ship. So what happens is you have an area where you have a ship, and the water is flowing. Okay, and sometimes the water flows and it just kind of flows slowly, and sometimes there's quite a strong current to the water. And so you have a boat. Let's see if I can kind of draw my boat here. I'm not a very good drawer. Here's my boat. So here's my boat, and I want to get my boat across this river or across a span. Well, as I'm going across the span, the boat will drift a little bit and be pushed. Even though the boat is looking and wants to go just this way, the boat actually, because of the current, ends up going in this direction. Okay? So, boat wants to travel that direction. Boat ends up traveling at an angle of 17 degrees because of the current. The current is pushing it in this direction, okay? So it's making it kind of go away from that horizontal that it wanted to go across, all right? This ends up to be a right angle. The boat is traveling at 23 knots. That's the force that the boat is getting, is exerting. We want to know what is this force right here. How many knots, and it would be the same units as what the boat is going, is the current pushing on the boat? Well, we have a right triangle, okay? We have a right triangle. That is a really icky right triangle. And in our right triangle, we have a reference angle, we have an opposite angle that we're trying to find, and we know what the hypotenuse is. Well, that lets me know that, hey, I need to use sine, that the sine of my reference angle, 17, equals the opposite angle over the hypotenuse. SOHCAHTOA is what I'm looking at. So there is what I have. So my reference, or my opposite side then, would be 23 times the sine of 17, which I got to use a calculator here, 23 sine of 17. I got 6.7. So that must be pushing, the current is pushing at a value of 6.7 knots on the boat. All right, let's look at another example. Now we have a force going straight west, and we kind of really going into generalizations here, and that's okay. So we have a Newton force pushing straight west. All right, and it has 1,000 newtons. And then another Newton force acting straight south on the same object. Now we've talked about this, that we could either draw it like this, like here's my object, and they have both the same starting point, and actually this one would be much smaller because it's not as big of a force, and this was the 50. All right, and then what we would have to do is we would have to draw our parallelogram, and then our answer here would be the diagonal of said parallelogram. Another option we had right away when we were drawing it is we could draw one here going the 1,000, and then instead of having the same, like if this was, oh, sorry, I have it in the wrong direction. It was going west. I apologize. So here's my start, and it's going west. All right, here's the end. And then the other one starts where this one ends. So this one, the 50, would go down from here. And then my result would be this. All right, notice how this result is the same. It goes in the same direction. It's going to be the same length. I like the triangle method better because you really can see that right triangle right here pretty well. And then you can kind of say, okay, what I need is, I need the magnitude and the direction. So let me start with the magnitude. Pythagorean theorem. 50 squared plus 1,000 squared. And that's equal to my resultant squared. Okay? 50 squared plus 1,000 squared ends up to be this value. And then when I take the square root of that value, I end up to get 1,001, about. We should do that, I suppose, to equal my r. So this is about 1,001. Okay. Now, we have to say, where is it? Well, we want to know where it is compared to a horizontal. This is considered my horizontal, so I'm really looking at what is that angle, all right? For that angle, this is my opposite side, and this is my adjacent side. So I'd be looking at the tangent of my angle equals my opposite over my adjacent. So to find that angle, we're going to go with the tangent inverse of that 50 over 1,000. Okay? Tangent inverse of 50 over 1,000, second tangent, excuse me, of 50 divided by 1,000. I got 2.8 degrees. So the degrees there would be about 3 degrees that I was looking at. Okay? So not a very big angle, but enough of an angle that it kind of shows why, and it's not a big angle because we have such a big Newton force here to a smaller Newton force here. I should have put newtons here, by the way, for my 1,001. Let me do another example. All right, Ben is pulling a wagon along level ground with a force of 18 newtons. So here, and we're getting this as a force of 18 newtons. And it makes an angle with the ground of 40 degrees. Find that horizontal and vertical components of the force. And this is really can be important in a lot of different considerations where you're going to have to find your y and your x here with different values. I'm just making it bigger here. All right, these are the ones where when we want to find your x value, you're going to use cosine. And when you want to find your y value, you're going to use sine. So there I went ahead and calculated our answer. You're just looking at, for both of them, doing some cross multiplication. All right, one last one here we'll set up. If an airplane is traveling at 256 miles per hour and it's impacted by a straight easterly wind of 65 miles per hour, how many degrees west of north should it take off in order to eventually go straight? So you actually see this phenomenon when you go to when you go to an airport, is if a plane wants to take off, sorry about that, and go straight, instead what happens is the wind is going to take it, and if it wants to go straight eventually, what you do is you don't actually go straight. You actually start off by going, oh, okay, I'm actually going to start and go off to the side, so that the wind actually pushes you back, so eventually you're kind of going in that direction. All right, so it kind of takes off. Usually it rarely takes off going straight. It usually takes off at a curve. All right, so that's what we're asking about here, is what should that angle be, is what we're talking about. What should that angle be that it takes off in that northwest direction? So it's going at 256 miles an hour. It's being impacted by the 65 mile an hour easterly wind. Okay, so what's this degree that it should be taking off at? Well, for this angle, for my reference angle here, this is my opposite side. This is my hypotenuse for that particular triangle. So for that one, I'd be looking at the sine. The sine of my angle that I'm looking at should be the opposite side over the hypotenuse. And if you remember, whenever you're trying to find an angle, you want to use your inverse. So we're going to take the sine inverse of 65 over 256. Okay, so my answer would equal the sine inverse of 65 divided by 256, which turns out to be, I didn't hit sine inverse, I'm so sorry, 65 divided by 256, about 15 degrees. So our answer is you should be going at a northwest 15 degrees, so that you, when, this was going this way, so when you're impacted by that easterly wind, you eventually are going straight or due north. And that's really kind of what you have to know and what you work at when you are flying a plane. Okay? I'm going to do one more. I have one more here. Plane travels at, let me see if I have one more, a couple more. Nope, just that one more. 400 miles an hour at 40 degrees north of east. So we have to figure out, okay, here's, if I was going in the east direction, north of east would be there. Okay, so there's my right triangle. So I'm 40 degrees north of east, and a plane is traveling 400 miles per hour. There is 50 mile per hour wind going west. All right. Find the magnitude and the direction of the plane. Interesting question. I think I'm going to wish that I wouldn't have started this. A plane travels at 400 miles per hour at 400 degrees north of east. Here's my east, 440 degrees north of east. It's going here. All right, and actually, okay, so it goes that direction.